Good morning, everyone, and welcome to week 29 of Human Circulation and Gas Exchange. My name is Jonathan Green, and today we are going to be looking at pulmonary ventilation and the adaptations of the respiratory system to gas exchange. In terms of today's learning outcomes, we've got two main overarching learning outcomes. The first one is to describe pulmonary ventilation and the adaptations of the lungs to enable gas exchange. So we're exploring the process of breathing and respiratory adaptations, and following outcome 2 is an application activity to apply what you've learned to describe the process of breathing, inspiration and expiration, and also to explain how different types of lung tissue have adapted to allow efficient gas exchange. Today is a cause for celebration. Today is the last taught session for this unit. After this, for the next couple of weeks, and I'll show you the calendar, it's ultimately starting to create responses for your now formative assignment for this unit, which is the part for the workbook. And also then after the completion of this unit, we'll then start looking at information to help you progress successfully towards your next destinations after you leave us, whether that's university or employment. So we are currently on week 29. As mentioned, this is the last taught session for this unit. Next week is Bank Holiday Friday, Victory in Europe Day, so don't forget that next Friday is a bank holiday, there'll be no taught sessions. Then weeks 30 and 31, essentially speaking, is you preparing your e-workbook to be submitted. As we mentioned, it has now gone to a what's called formative or low stakes assessment, which basically means you are not going to be given a final grade for this, e.g. pass, merit or distinction. We will be calculating grades for these final units, and human circulation gas exchange is one of them. And essentially speaking, that is the final aspects of the course. Then what we'll be doing then is starting to prepare for higher education, and any information that we can give you, we will do. So, as a reminder, last week's YouTube lecture is now available on both YouTube and Google Classroom, so make sure that you take a look at it if you couldn't make the Google Meet chat last week. And also, after completion of this will also be going on YouTube as well. So there's two topics that we're looking at today. We're looking at ultimately breathing, which is called pulmonary ventilation, and also how lung tissue is adapted to enable efficient gas exchange. So as a starting question, and I'd suggest that you pause this before you start to give yourself some thinking time, is what do you already know about pulmonary ventilation? Well, pulmonary ventilation is ultimately an anatomical way or a medical way of saying breathing. It is the processes and mechanics of both breathing in and breathing out, what is called inhalation or inspiration and exhalation, expiration of air, and involves the exchange of air specifically between our atmosphere and also the lungs. Inhalation is the inflow of air, exhalation is the outflow of air. Inhalation, this ultimately is the active part of a breathing process, which is why we generally can call it sometimes linked to the mechanics of breathing. This is initiated by the respiratory control centre in the medulla oblongata. As we've looked at within the cardiac cycle, the medulla oblongata also controls the cardiac cycle by what's called the cardiovascular control centre. This also regulates breathing as well. This initiates ultimately the contraction of the diaphragm and internal intercostal muscles, causing your thorax to expand and decrease in pressure, which in turn allows air to enter the lungs and breathe in oxygen. And oxygen, as we know, is a key for human survival. We need oxygen for cells to survive, to respire, to create energy, to metabolise. Exhalation, on the other hand, is the inactive part of the breathing process, unless it is forced. So generally speaking, once we inhale, exhalation will occur through elastic recoil, a bit like an elastic band. Therefore, it's generally speaking an active process unless you what's called forced expire, which is where you breathe out as if you were, for example, blowing air on a winter day to try and see the steam that's coming out. when it becomes force and active, what happens then is you will use extra muscles or additional muscles to contract. For example, your abdominal muscles and your internal intercostals will accelerate expiration by increasing pressure. By doing that, it forces the air outwards to expel what we think is the waste, such as carbon dioxide and other toxins in the body. The next part of today's aspect is looking at what do we know about the lungs that enables them to allow gas exchange, and also what adaptations of the lungs have we got. So what is gas exchange? Well, ultimately gas exchange is a delivery of oxygen from the lungs to the bloodstream and the elimination of carbon dioxide from the bloodstream to be sent to the lungs to be removed. In simple terms, we need to get oxygen from the air to move into the blood, and we need to remove waste such as carbon dioxide from the blood back into the air. This occurs within the lungs, specifically within the alveoli and capillaries. Now, for this aspect, we need to look at how has the lung adapted. So what do we actually mean by an adaptation to the body? Well, this in a biological sense refers to the process of change by which we become better suited to our environment. And there are different types of bodily adaptations that ultimately you can explore. For example, evolutionary adaptations, acute physiological adaptations, and chronic physiological adaptations. Adaptation in an evolutionary term is the process that species such as us go through in order to become accustomed to an environment, and over many generations and through the process of natural selection, physical and behavioural features adapt to function better in the face of environmental challenges, such as our body has developed lungs to be able to breathe atmospheric air. Ultimately, if we were a water-bearing species, our lungs will have adapted in a different way, for example, absorbing oxygen through water, for example, through gills. We've also got acute physiological adaptations. These are also known as short-term adaptations. So an acute physiological responses refers to an immediate response of one or more of our body systems, for example, during exercise, such as the breathing rate as you start to participate in some form of physical activity. These responses are vital as it plays a vital role in having the ability to respond to the changes and demands that have been placed on our body in that immediate moment. So for example, just the act of getting up in the morning and walking to the bathroom requires this type of response. It requires your heart rate to increase slightly, your breathing rate to increase slightly, hormones to release, and also increases in neuromuscular activation. Without these responses, we'd simply not be able to get up in the morning, let alone exercise. So these very small changes are required in both the cardiovascular and respiratory systems to meet the short-term demands. If you start running, the likelihood is you will start to increase your heart rate, you'll start to increase your breathing rate because you'll need more oxygen, you'll need to remove more carbon dioxide. Finally, we've got what's called chronic physiological adaptations, which these develop over time and allow us to cope with demands more efficiently. For example, if you're not very fit, for example, and you decide to go for a 5k run, you'll most likely find it hard on the body's various systems, as your heart rate will rise sharply and also your breathing rate will increase rapidly as well. And you'll also maybe find over a couple of days that your muscles might become sore through a process of what's called delayed onset of muscle soreness. If you don't do any exercise for a few weeks and you try and repeat the same process, the likelihood is you'll get your same outcome. Your heart rate will rise sharply, your breathing rate will increase, and your muscles will always be sore. However, one of the great things about our body is the ability for it to adapt, what we call long-term chronic physiological adaptations. So instead of doing, like, for example, a 5 kilometre run in 3 weeks, if you do to something form of exercise every single day to build up towards that 5 kilometres, your body, essentially speaking, would adapt. This is because you're repeatedly asking your body to do more happen more and more, and it feels that it needs to adapt in order to meet this physical demand. And essentially speaking, it would cause adaptations. And we'll start to look at these chronic adaptations specific to lungs and lung tissue. So evolutionary adaptations of the lungs is that, essentially speaking, our lungs have adapted to give us what's called alveoli, which are tiny air sacs. Ultimately, are the site of gas exchange. They have a large surface area, and there's many of them present in the lungs. And having a specific shape, which we'll look at, increases its surface area, which means it can uptake more oxygen and remove more carbon dioxide. It has thin cell walls, and having a thin wall basically means diffusion can happen much more efficiently. And also, the alveoli are permeable. The tissues within the alveoli allow gases to pass through. So looking at the importance of surface area for the alveoli, it's adapted to have one to enable more efficient gas exchange. So the surface area of your lungs is absolutely huge because of this adaptation. It's approximately 100 metres squared, which is about the size of a tennis court. And if we have a look at the diagram just to the right of us, ultimately we can see how the surface area can be increased by, for example, having smaller spheres collected together rather than just one large one. Ultimately, this increases the surface area by up to 4 times. And as well as this, lung tissue has the ability to be able to participate in gas exchange by using just under a litre of blood at one point. So essentially speaking, we have got 5 litres of blood in this body. Approximately 1/5 of your total blood volume will be at the site of gas exchange within your lungs. Other evolutionary adaptations includes having moist tissue and cell walls. So this enables gases to dissolve within this moisture to help them pass through, and also the extensive blood supply. So ultimately, 1/5 of our blood, or there or thereabouts, is taken away from the lungs to be able to participate in gas exchange, as well as having a large diffusion gradient as well. Now, chronic physiological adaptations, so adaptations to our environment that we can change ourselves, is having increased lung capacity. So by exercising regularly and participating in aerobic exercise, lung tissue has the ability to increase their own ability to expand, which means you can breathe in more air and move more air out. It also increases the strength of respiratory muscle tissues, such as your diaphragm and your internal intercostal muscles. This results in the ability to be able to breathe in more air and to expire air more rapidly. Your lungs increase the amount of capillaries that are around the alveoli, and that, essentially speaking, increases the amount of oxygen and carbon dioxide that can be removed and brought in. And also an increase in alveolar tissue. The numbers of alveoli in the lungs increase as a result of thinking that your body needs to adapt more to be able to meet the demands of what it is that it's doing. So his body can also increase the amount of alveolar tissue that we've got in his body as well. And essentially speaking, that is both tasks and topics that we need to be looking at today. So for outcome 1, we need to describe pulmonary ventilation and the adaptations of the lungs to enable efficient gas exchange. So we're looking at both of them topics and creating a response, which I'll show you what you need to do for that. Then to then complete pages 12 and 13 of your e-workbook. So, using literature under week 29, pulmonary ventilation and adaptation of lungs for gas exchange, as well as conducting your own research. Ultimately, there is a formative task on Google Classroom for you to complete, which ultimately is to describe the processes of ventilation via explain what the mechanical events are of inhalation and exhalation, and also to explain 2 adaptations of lung tissue that enables it to enable efficient gas exchange. Submitting and in for feedback, and I'll be able to give you some feedback on your progress on that once you've completed it. And once you've completed that, you then can apply it into your e-workbook, which now, as we previously mentioned, is a formative assessment. Complete pages 12 and 13, and that essentially is the last topic for this unit. These are some references that I've used today, as it is going online onto YouTube, so if you want to take a look at these as well, please do so. Next week, as a reminder, is bank holiday due to V-Day, so there'll be no taught session. I will be available Monday and Thursdays. And essentially speaking, we've covered all the content now, so it's now a case of you applying what you've learned and to compile responses for your e-workbook. And that is everything for today's session. If you've got any questions or anything, please do email me. Quite happy to respond and help you on your way.